All right, so this time around we're going to take a look at air pressure and what that has to do with wind. So we're just going to get the very basics this time. So air pressure can really just be defined as how much weight is pushing down on you. So when we look here at these two, for example, there's only one person on top of them, so they have less weight on top of them. Whereas, of course, these three have much more weight because they are holding up these three people. Air pressure really works the same way. So these three are under the most amount of pressure, the most amount of weight from the people above. Air pressure works the same way. The only difference is we have air molecules, okay, pushing down. So down here, more air pressure. Here, less air pressure. And here, the least. So this shows it really pretty well. So again, up here, they feel a little weight or a little pressure because there's really not much above them. Whereas down here, they have lots of weight pushing down, so she feels a high amount of pressure. Same thing over here. So this time, we've just replaced it with air molecules, and we can see, of course, well, there's a lot of air molecules pushing down. The more air molecules pushing down, the more air pressure. So above you, even though we can't see the air, they're too small to be able to see, there is air pushing down on top of you. That is air pressure. So we can also then look at the Earth. And so here, of course, is our atmosphere surrounding Earth. Okay? The closer to the surface we are, the more air on top of you pushing down. Whereas up here, not as much air on top of you, not as much weight. And here, and that's really what air pressure is. How much weight from the air is pushing down on you. Okay, so again, this shows air molecules. It just shows it as a column. Okay, so down here, more air pressure, less air pressure. Less air on top of you versus here, much more air on top of you. So in terms of a review, remember air is matter. So even though we can't see these individual air molecules, they're just too small, we know that they do take up space, like what this picture is showing here. Okay, so air does take up space. And because it takes up space, it does have weight to them. It just doesn't have as much weight as, of course, a person does. Okay, so the more air you have above, the more air weight there is. So the more air weight above you, the more weight from that air is going to push down on you. In other words, the more pressure you're going to have. So this would be a lower pressure and a higher pressure. Now, air pressure then is also can be related to density. So the greater the density of the air, the greater the air pressure. Okay? So there are more air particles basically pushing down on top of you. Okay, and this next page will kind of show that a little bit better. All right, so this page really looks at air pressure in an analogy. So think about density. So we have this person right here, and this person here, okay, and they're holding up this box. Okay, so this person's holding a box with a less dense amount of people in it. So this box is the same size, they're only holding 2 people. This box is more dense, but holding 5 people. So obviously this one's going to push down, okay, with less pressure than this one over here. So more dense things are obviously going to have more weight to them. In other words, they're going to push down with more pressure. Now, let's replace that just with air particles. So let's say above this person, we have air particles that are spaced like this. Okay, well that's going to have less weight, lower pressure pushing down. This is the same size circle, but our air particles are much closer together, so they're going to have more weight, so it's going to push down with more pressure. So that's what we mean when we say a greater air density means more air pressure. Because the particles are closer together, there's more of them, they have more weight, pushed down with more weight, thus a greater pressure. Now we can also look at that in terms of temperature. Okay, so we have this little video here, and notice as we turn on the heat, these air particles start to spread out more and more and more. They move faster and faster and faster. So in other words, they're getting less dense. Okay, so a higher temperature simply means a lower density. Whereas now that we add our ice right here, well, that's going to cool it off. So these particles get closer and closer together, okay, and eventually they'll kind of fall towards the bottom, and we're going to get more and more dense. So temperature and the density is related. Colder temperatures, higher density. Warmer temperatures, lower density. So when you look at a high temperature, well, our air particles are farther apart. So let's say that this is our area. Well, that means then this is going to be lighter, okay, because it's made up of fewer air particles in that same amount of space as what we have over here. So if we cool off our area, then our air particles take up a smaller amount of space. They're closer together. We have the same space right here that we're looking at, so this is going to weigh more than this one over here. So a lower temperature is going to weigh more. In other words, it's going to have a higher pressure pushing down. It's going to weigh more. So again, you can kind of think of it like this in terms of holding it up. This lower temperature, colder spot over here is going to weigh more. So it's going to push down more on this person, higher pressure. Whereas this one over here, warmer temperatures, less dense, fewer air particles, it's lighter. It's going to push down less, so less pressure on that person. That's how air pressure and temperature then are related. Okay, and so that's it. Hopefully it makes sense in terms of how air pressure works with temperature and density, and how it really is just weight pushing down on top of you.